Hi everyone, and welcome to my video journal critique. Today, we're diving into a fascinating study published in PLOS1 by Giuriotto and colleagues in 2021 entitled Allometric Association Between Physical Fitness Test Results, Body Size Shape, Biological Maturity, and Time Spent Playing Sports in Adolescents. The central problem this paper addresses is something coaches and PE teachers see all the time. When two adolescents perform differently in a fitness test, how much of that difference is due to actual training and how much is just due to them being taller, heavier, or maturing earlier? The authors used a sophisticated statistical tool called allometric modeling to untangle these factors. The goal was to see the true impact of biological maturity and sport participation, once the confounding effect of body size and shape was removed. The research included 771 adolescents, both boys and girls, aged 14 to 19. They measured three core physical fitness components using standard field tests, like number 1, standing broad jump for lower limb explosive strength. Number 2, sit-ups for trunk strength endurance. Number 3, shuttle run for speed and agility. The genius of this paper is the use of allometric model. It mathematically adjusts the fitness scores for three key body characteristics: height, mass, and waist circumference. Once that size noise is cleared, they could accurately test the impact of their other variables, like EHS for extra hours of sports after school, and MO, maturity offset, or how far the adolescence is from their peak height velocity. The findings were remarkably consistent across all three fitness tests: the SBJ, the SUP, and the SHR. After controlling for body size, two factors consistently stood out as strong, positive predictors of better performance. First, extra hours of sport. More time spent training after school was associated with a higher skilled performance in explosive strength, endurance, and agility. This validates the common sense idea that practice makes perfect, but it does so even after accounting for physical size. Second, maturity offset. Being an earlier biological developer was also significantly associated with better skilled performance. This means that advantage of maturing earlier isn't just about being bigger. It translates to better motor performance capacities. Furthermore, the analysis of sport type showed interesting differences. Participants in team and individual sports generally had better skilled performance than those who reported no sport activity. For example, in the sit-up test, team sport, boys showed a high mean performance, underscoring the benefit of structured, regular sport engagement. So what does this mean for us, coaches, educators, and health professionals? The most crucial takeaway is that we cannot trust fitness scores alone for talent identification. A coach might select a bigger, earlier maturing athlete simply because of their size advantage. This study proves that using allometric scaling can help identify the athlete with truly superior motor capacity, regardless of whether they are a late bloomer or smaller in stature. It helps prevent prematurely deselecting high potential athletes. The strong link between extra hours of sport and scaled fitness is a clear recommendation. We should prioritize interventions that increase quality sport participation and strength and conditioning work among adolescents, knowing that these activities provide genuine benefits to motor performance, independence of natural growth. I recommend that youth sport organizations and school physical education departments explore adopting scaled fitness assessment models. By adjusting for size and maturity, we ensure fairer evaluation and better guidance for all young athletes. In conclusion, this paper successfully applied allometric modeling to provide a nuanced, size-independent view of physical fitness in adolescents. It confirms that both consistent sport participation and biological maturity are vital determinants of motor performance. Thank you for watching.